Alright, this is 1.8 calculations of volume, molar volume basically. So it's defined as room temperature and pressure that any gas will contain 24 liters per mole. RTP is defined as 1 atmosphere or 101.325 kilopascals and 20 degrees Celsius or 293.15 Kelvin. So you can see here, no matter what substance you have, sodium or water, if it's a gas, it's going to be the same number of moles, same number of liters, same number of atoms. That's because the size of atoms and molecules are so small that it's relative to its space. So for example, to convert moles to liters at RTP, room temperature and pressure, it's just a simple division, multiplication of your constant, 24.0 liters per mole, times your moles, and you get 9.6 liters. Here you calculate the mass of a given volume of methane. So at RTP, so if you have mass, you got to start with your liters to get to moles. So it's a simple dimensional analysis to convert milliliters to liters using your constant. 1 mole is 24 liters times your molar mass. You get 0.0802 grams of methane. Alright, here's your homework assignment. 2 problems, page 19, number 19. You need to find the volume occupied of carbon dioxide, CO2, if you have 26.4 grams at RTP, room temperature and pressure. And letter B is to find the mass of helium of a given volume, 120 milliliters, at RTP. Alright, gas, volumes, and stoichiometry. Basically, you have volume of a gas, and we'll give you the same molar stoichiometry as the balance equation. Therefore, equal volumes of gas will equal the number of molecules and equal the moles of the gases, all the same ratios. That's again because of the size of particles. So in other words, the ratio between the volumes of the reactants and products is the same ratio as the moles of the reactants or products, stoichiometric ratio. Here you have example. We have hydrogen plus oxygen yields water. If you balance it, it's a 2-to-1 ratio between hydrogen and oxygen. They're your gases. Water is a liquid, so it can't be used as molar volume. So you can see here you have 20 milliliters of hydrogen and 10 milliliters of oxygen. It's a 2-to-1 ratio, just like the mole ratio. Here is an example to find the formula for propane and the stoichiometric equation of your reaction. So let's say we don't know what propane is, even though we know what propane is. Reacts with oxygen, makes carbon dioxide and water. Here's your given volumes: 50 centimeters cube of propane, 250 of oxygen, and 150 of carbon dioxide. Knowing those volumes, you can figure out the stoichiometric ratios by doing large over small. So oxygen would be 5, propane's 1, and carbon dioxide is 3. Just divide large over small. So if you know the volume ratio, we know that the mole ratio is the same of 1, 5, and 3. Again, water is a liquid, so it can't be used. So from that information, we know it's 1, 5, and 3 as your coefficients. So we can do a little math to figure out what our formula for propane is and the other coefficient for water. So X, carbon, is the first one we can find because hydrogen cannot be found because we don't know the coefficient for water. But we know there's 3 carbon dioxides. That means there's 3 carbons for propane. Now, since we know there's 10 oxygens on the reactant side, that means there needs to be 10 oxygens on the right side. From CO2, there's 6, 3 times 2. That means you need 4 for water, so the coefficient for water is 4. And then knowing that, we can figure out that the Y for propane has to be 8 to match up with 4 waters. 4 times 2 is 8. Alright, second homework question is to do the basic same thing. Well, in this case, we have 50 centimeters cubed of gaseous hydride of phosphorus, PHN, we don't know what N is, reacts with exactly 150 centimeters cubed of chlorine gas, Cl2, to form liquid phosphorus trichloride and 150 centimeters cubed of hydrogen chloride gas. Since it's a gas, it's not hydrochloric acid, hydrogen chloride. So A, find how many moles of chlorine gas react with 1 mole of gaseous hydride. Deduce the formula of the phosphorus hydride. And to write the balance equation for the reaction. Okay, good luck. And if you have any questions,